Today's assignment is 18.2b, and it is mostly review from 18.1 again. If we were in class, instead of being on this online distance learning stuff, we would have done a couple problems together, worked some on a unit circle project, maybe started the 18.2c notes, which is the first new thing in the 18.2 section. But I felt the need to work out some problems for you. These are totally optional if you think you remember everything from 18.0, 18.1. But a couple of them kind of twist what we already know in a different way. So I'm just going to do some, skim through, look at whichever problems you need help with. These are numbered like problem numbers from the assignment because that was the easiest way for me to make up some good sample problems for the notes. But these are not from the assignment. These are just extra problems I made up to review. Okay, first section, find the measure of each angle in radians or degrees, depending on the original form. Some of you on the last quiz were changing everything to degrees because you like degrees better. You're allowed to do that. But then, if they ask for the reference angle, it has to change back. I'm going to work in degrees when it says degrees, radians when it says radians. My final answer has to be in the same format they originally gave me. So I'm looking at the first one. And the first thing I want to know is it positive or is it negative? Because it goes up first, starts here and it goes up, I know it's positive. So I'm just going to put a plus sign on my answer. Not at all required, but it makes me remember that I thought about it already. On the second one here, it goes down first. So my answer for this one is going to be something negative. And I know I lose track and I forget to write down the negatives if I don't do it first. So looking at the first picture. Now let's throw some degrees, radians, degrees on this one. 0 degrees, 180 degrees, back to 360 degrees. Since you're not required to label those numbers, if you left off the degree symbol, that'd be okay. But my final answer is in degrees, and it is required for the answer. So what do we have? I see one full circle. That is 360 degrees. And then, looks like I see another full circle around here. There's another 360 degrees. And the rest is not a full circle. What else do I have? Just a little bit more. And I didn't label the top line, but half of 80 is 90. So this is a 90-degree section. They told me about the 65, but I don't want the 65. I want the other part of it. So 90 minus 65 should be 25 degrees. So I need to come down here and I need to add another 25 degrees to this. That is 745 degrees. Bring it down here, 745. Don't forget the degree symbol. I don't care whether or not you put that plus sign in there, but you do have to have the degree symbol. Let's look at the second one. The second one also has more than a full circle. Some of the ones in the assignment do not have more than a full circle, but I just picked out ones that did. So I'm going to say, starting down so it's negative, full circle around, makes 360 degrees, but we're not in degrees. So I'm going to have to pause and think about 0, pi, 2 pi. But because the only fraction I know has a 9 on the bottom of it, I'm going to call my pi 9 pi over 9, because 9 over 9 is 1. And I'm going to change my 2 pi into, still need that 9 on the bottom, and 2 times 9 is 18. Notice that when I did double to get my 2 pi, I only did times 2 on the top. If I did 2 times 2 on the bottom also, I'd have 18 over 18, and it'd still be 1 instead of the 2 I'm looking for. So when I go to add this up, I've got 1 full circle, which is 18 pi over 9. And what do I have next? Let's say I have a half a circle. So I have a 9 pi over 9. And I have a little bit more. So just like over here, I stopped and figured out that one was 90. I'm going to stop and figure out half of 9. I could call this thing 4.5 pi over 9, which is a little strange. But that means each quadrant, eventually I'm going to have to change it, but I'm going to leave it this way for now, is 4.5 pi over 9 for every quadrant. Easiest to see it in the first one, but it's true for every quadrant. And out of that 4.5 pi's, I used up one of them right here. I'm looking for this piece here, which must be the other 3.5 ninths of pi. I'm just going to bring it down here. Say plus 3.5 pi over 9. And say all of that, 27, 30.5, 30.5 pi over 9. Now seriously, would you write that for a final answer? I hope not. I need to have the top as a whole number. Since the top has a 0.5 in it, I can change it into a whole number just by multiplying by 2 over 2, which makes the bottom of this 18, and the top is 2 times 30.5. 2 times 30 is 60, 2 times 61 pi over 18. So my answer here is 61 pi over 18. And even though this means the same thing, nobody's going to put a final answer down with a decimal in a fraction. Not good. Okay. I put this little unit circle here with the degrees on it so that you could look at it and use it to guide your way if you wanted to. But it really wouldn't have been much help with these radians because the radians are ninths. And even when I draw the radians on this circle, I don't get anything in ninths, so it doesn't help me very much. Okay, let's look at our next example. I think there are maybe 3 degree ones like this and 3 radians ones like this in your homework. Angles already drawn, you have to figure out the measure. And then we have some where we have to figure out what it looks like. They told us the measurement, we have to figure out what it looks like. Notice that again, I started with drawing in my initial rays, solid enough so that you can see them on top of the other arrows. Some of you lost a half a point on the last homework quiz because you forgot about that. I don't know how you can forget about that when every single time I do a problem for you, I do that first. I cover the whole page in little arrows. I wonder if there's any on this side. Nope, I only did a couple of them. Okay, let's do the degrees, then let's do the radians. Again, I'm going to think it through and say 0 degrees, 180 degrees, 360 degrees. You don't have to write those measurements, but they help to see what's happening. This one's negative, so I'm going downward. 275 is not a full circle. Let's think about this. Half of 180 is 90. I'm going around the circle, I'll get 90. Plus 90 is 180. Plus 90 is 270. plus 90 is 360. Goes off of there for a minute. So this would be 270 degrees. If I'm going backwards, instead of calling this 270 degrees, I'm going to call this negative 90 degrees. Instead of calling this negative 90 degrees, I'm going to call this one negative 270 degrees. And then this one gets to be negative 180. You don't have to label them that way, but for me, that helps. So I'm going to go 180. Actually, I'm going to go 270 degrees in the negative direction. And that's not quite far enough. So I need a tiny, tiny bit more. And yes, I put an arrow on that. And I bring this one over to meet it. And I put an arrow on that. Those little arrowheads lost people half points on the last quiz. There's negative 275 degrees. It wasn't more than 360 degrees in the negative direction, so it didn't have to have all those extra spirals we saw in the front ones. Okay, let's look at number 4 here. We have something with a 3 on the bottom. So when I'm setting up my numbers, 0, pi, 2 pi, I'm going to make this 3/3 because it's still 1. And I'm going to make my 2 pi into 3 on the bottom and 2 times 3 is 6 on the top. I'm drawing 11/3 of pi. A whole circle is only 6/3 of pi. So let me first draw my full circle. Positive going up. Start near the center because I know this one's going to have to spiral outward some. There I want 11 pi over 3. I drew 6 pi over 3. I still have another 5 pi over 3 to go. Okay, I've put the words that I often put in there. I want 11 pi over 3. I've already done 6 pi over 3. So I have 5 pi over 3 left to go. If I go 3/3 more, I'm going to need another 2 pi over 3 again. So 2/3 more. Well, if half a circle is 3/3, then I need another 1/3 of the quadrant, which means about 2/3 of the way down here. If you're a little lost, you can look at this and say, I need another pi over 3. I see that pi over 3 is 2/3 of a quadrant, so I'm going to draw this one at 2/3 of a quadrant. And some of them, you were doing them. There we go. That covers everything. Let's look at the next thing. What else do we have to do today? Find a coterminal angle between 0 and 2 pi for each given angle. And I don't know if your homework has them all in radians or some in radians and some in degrees. But we're going to remember that when we do coterminal, that's both of it. When we go coterminal, we're going to add or subtract a full circle, which means we're going to add and subtract 360, or we're going to add and subtract 2 pi. But when we do 2 pi, we're going to match the denominator. Okay, it's to show you work with a sketch and or calculations. I do just a little bit of a sketch to get a feel for what I'm doing. Zero, pi, 2 pi. Since there's a 12 on the bottom, I'm going to call this 12 pi over 12. And I'm going to double that for my 2 pi and call this 24 pi over 12. I want a coterminal angle between 0 and 2 pi. So it really means between 0 and 24 pi over 12. That is too big. I will subtract a full circle. (17 pi over 12). I don't have to draw it. It didn't say I had to draw it. Is that a number between 0 and a full circle? Yes, it is. Okay, let's look at the next one. The next one has a 45 on the bottom. So I'm going to start with sketching a picture. And for my picture, I'm going to say 0, pi, 2 pi. Because this has 45 on the bottom, I'm going to call my 1 pi 45 pi over 45. And double 45 gives me 90. So I'm going to call this one 90 pi over 45. When they say find an angle, coterminal angle between 0 and 2 pi, they're really talking about between 0 and 90 pi over 45, because that's 2 pi in the form that works here. This time, it's too small. It's negative. So instead of subtracting a full circle, I'm going to add a full circle. Plus 90 pi over 45. And really, I keep the pi, I keep the 45. I just have to think about what's negative 19 plus 90. That is 71 pi over 45. Is that between 0 and 90 pi over 45? It is. Sometimes you have to end up reducing those answers. I don't remember right now whether any of them in our assignment need to be reduced. But when you think about them, reduce them if you can. Okay, next page. Let's see what else we have. To state if the angles are coterminal. So instead of finding coterminal angles, they want to know, are these angles coterminal? On the 18.1a assignment, the very last problem, we said, which of the following angles are coterminal to 300 degrees? And we had to start with 300 and add a bunch of times, subtract a bunch of times till we caught this. So we have two choices here. We can start with a small angle and add and add and add until we see if we can match the big one. Or we can start with the big angle and subtract, 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 and still we see if we can match the small one. Personally, I'd rather add. Even though when you're adding to a negative, it kind of feels like subtracting. So I'm going to start with the smaller angle here, which is the negative one. And I'm going to add 360 because 360 is a full circle. That's 235 degrees. And 235 degrees, that's what we were looking for. So I don't circle 235 degrees because it's state if the given angles are coterminal. The answer to this is yes. Let's look at the other one. This time they're both positive. I'm going to start with the small one and I'm going to add 360 degrees. which is 500 degrees. Not there yet, so add another 360 degrees, and it matches up perfectly to 860 degrees. So again, my answer is yes. But the question is, how would it have ever been a no? What if they gave me, I should have made up a good no example, but what if they gave me 140 degrees and they gave me 900 degrees? Then I would add the 860, and when 860 didn't match, I would add another 360, and you would say, wait, I got too small and then I got too big, so I would have had to say, nope, those are not. But this time they didn't ask me for that. And that's how you would get a no out of there sometimes. If you keep adding and you go past it without ever reaching it, then you know it's not it. Okay. Find the reference angle in radians or degrees depending on the original form. When we did reference angles before, we always drew the picture. I don't think you have to draw the picture this time, but I'm going to do just a little bit of a sketch again to see if it helps. A basic sketch, 0, 180 degrees, 360 degrees. Since the sketch is not required, who cares if you remember what degrees on there? And I need to think about 475 degrees is bigger than 360. I need to get it down to something reasonable before I can figure this out. 475 degrees minus 360 degrees. That's what it would look like if I drew a full circle. I don't have to draw it. Just keeping track of where 0, 180, 360 are should be really enough for me. I have 115 degrees after I take care of that full circle. So now all I really need to know is 115 degrees closer to 0, 180, or 360? I think that 115 is close to 180. I haven't even drawn it yet. But number-wise, it looks closer to 180. So I'm going to say, what is 180 minus 115? 65 degrees. So this is going to actually end up over here 90 and some over there somewhere. Really rough sketch because the sketch isn't required. It's going to end up 65 degrees away from that 180 degree angle. Let's look at the next one. Oh, before I go to the next one, some of you were writing down reference angles on the last quiz as being something over over 90 degrees. It's never over 90 degrees. And even if it's down below the line, it's never negative. You always give a positive answer, and it's always going to be between 0 and 90. Next one is 19 pi over 6, negative 19 pi over 6. So I'm going to think about a sketch again. 0, pi, 2 pi, because that has a 6 on the bottom. I'm going to change my pi into 6 pi over 6, and I'm going to change my 2 pi. I always erase half that 0, don't I? I'm going to change my 2 pi into 6 on the bottom, and 2 times 6, 12 pi over 6. When I look at my negative 19 pi over 6, it's more than a full circle in the negative direction. I want to get it back into the positive direction so I can see what's going on. So I'm going to add a full circle. This is always kind of dealing with coterminal so that I can say, let me get it another angle that's in the same place. It has a more reasonable number to work with. This one gives me negative 7 pi over 6. It's still not between 0 and 12 pi over 6. So I think I will take that one and add another 12 pi over 6. So now I have 5 pi over 6. So it's going to be, here's 6 pi over 6, it's going to be over here somewhere. It's got a couple spirals in it because I had to readjust, but I don't care. I just want to know about where it is. So if this is 5 pi over 6, and this is 6 pi over 6 right here, how far is it to the nearest part of the x-axis? Pi over 6. That's my reference angle. And I know I talked about this a little bit before, but I'm going to say it again. If the bottom of your fraction is 2, 3, 4, or 6, then your reference angle is going to be pi over whatever number you have there. When it's not a 2, 3, 4, 6, when it's something like 57 pi over 20, that's not going to help you. You're going to have to just deal with it by actually looking and counting it out. But this is just a shortcut. Because it had pi over 6, I knew that its reference angle would be pi over 6. And in fact, if you can memorize that, then I won't make you show work on that type of problem. In other words, if somebody asks you to find the reference angle for negative 272 pi over 3, without any other calculations, you could say reference angle is pi over 3. However, if the bottom of this, instead of being a 3, was a 13, you couldn't do that. You'd have to go through the work of figuring it out. Okay, what else do we have on here? How many did you do? That's all my examples for that. I will do a video with some actual problems from the assignment, but I may not do it till after the Zoom meeting so that you have a chance to ask me for which ones you want before I work any of them out.